and remember what big K is. It's just an equilibrium constant. We would calculate the KSP. So that's where those numbers come from. So that's just one way that you can use those KSP values to find ion concentrations in solution. You remember when we talked about solutions way back, ionic compounds can be very soluble, such as calcium chloride, very soluble, but calcium fluoride would be slightly insoluble. So how do we deal with that? Well, what we have is a KSP, and that stands for solubility product. And remember what big K is. It's just an equilibrium constant. And so these are values that you can look up in tables at a given temperature, and it will indicate basically how soluble an insoluble compound is. So on this table, the most soluble of these would be the calcium sulfate, and then it looks like the lead carbonate would be very insoluble. And so the magnitude tells you relatively how soluble these things are. So let me show you where these come from. So let's say we had calcium fluoride and we wanted to write the dissociation reaction for that. So it would dissolve into calcium ions and fluoride ions. And notice there are 2 fluoride ions there. And then if we wrote an equilibrium constant expression for this, we would get the calcium ion. Remember, we only include things that are gas and aqueous. We don't include that solid sitting over there on the reactant side. So that's our expression. And if we plugged in the concentrations of those 2 ions at equilibrium, we would calculate the KSP. So that's where those numbers come from. Now let me show you one way that you will use these KSP values. So let's say we had this solution and we want to know what is the calcium ion concentration in a calcium carbonate solution. Well, first thing we've got to do is write that dissolution reaction. So it's going to be in equilibrium with the 2 ions, calcium and the carbonate ion. So KSP, the expression would be the calcium ion concentration times the carbonate concentration. All right. Now KSP is a known value, so I'm going to go over there to my table and get that. Calcium carbonate there. You probably have a table in the back of your book. You can Google those things, you'll find those. So 5 times 10 to the -9th. So I'm looking for the calcium concentration. Now, I don't know the carbonate concentration, but here's what I do know. When 1 calcium carbonate dissolves, I get 1 calcium and 1 carbonate. So I'm going to say let X equal the concentration of calcium. And I know that carbonate concentration is going to be the same thing. So if I substitute, I'll get X times X. So that's an X squared. So X is going to be equal to the square root of that KSP in this case. And that is going to be 7.1 10 to the -5th molar. Now what was that? That is my calcium concentration there. And so we calculate that. And it's also the carbonate concentration in that solution. So that's just one way that you can use those KSP values to find ion concentrations in solution.